everyone. I'm so happy to see so many participants have joined this webinar. We're excited to have you here with us. We haven't done a webinar for a while, so this is going to be a special one, and we're going to have a series of these. So stay tuned. So this webinar is about reducing cost and how to operate large-scale clusters, both Elasticsearch and OpenSearch. So first, an intro by me. I'm Ziv, the CEO and co-founder of Opster. After the intro, we're going to move to Sachin, who is going to talk about how to reduce cost of Elasticsearch and OpenSearch clusters. And then a session by Marcos about how to solve latency and performance issues in large clusters. We're going to keep some time in the end for question and answers, so feel free to write questions along the talks, and we will get to them in the end, so stay tuned. So first, before we dive into the slides, let's talk for a second about Opster. We're here in the business for more than 4 years. The team with more than 10 years of experience in Elasticsearch. We have developed AutoOps among other tools. AutoOps is a cloud service that enables optimization of performance and cost reduction. It works both with Elasticsearch and OpenSearch. And like I mentioned, in Opster, we have a team of search experts, both for the operation and for the consultant and professional services, all with many years of experience. And this is an important team. You're going to meet Sachin and Marcos and that are part of this team. It's an important team working both with customers, but also shaping our products to suit the challenges in production we're going to talk here. We also contribute a lot to open source or open source and the open source community. We have many guides and articles and tools, and worth mentioning the Kubernetes operator that we open sourced among many others. There are more than 20,000 users that uses Opster free tools and open source services. And the team is going to show you in the slide some of the free tools you can use yourself to gain more visibility and help. And Opster services are trusted by thousands of companies. We have Fortune 500 companies and startups all using our services. And just before I'm done, let me talk a little bit about the slides. The insights that you're going to see here are based on analyzing more than 16,000 clusters by Opster tools. And the cases are real time. We have real customers with all these edge cases and supporting mission critical application across multiple industries. Provided us many cases to handle and experience and knowledge. Sorry for that. Let me close that. So the talks are based on the knowledge we got from working on these cases. And the last is that Opster technology provides solution for many of these challenges that you're going to see here. So we didn't take the time just to show you our tools. The solution the team will provide is how you can do it yourself, how you can analyze with the open and free tools available out there. We have our technology that we provided that helps mitigate that even faster and easier. Okay, that was my intro. We'll now move to Sachin, so you can share your screen.
Thanks, Ziv.
Welcome.
Let me share. Okay. Hello, everyone. Yes, I second what Ziv said. It's great to see so many participants in this webinar, and I'm very excited to share some tips and tricks to reduce the costs of running your Elasticsearch and OpenSearch clusters. Let's kick it off with the major factors influencing costs in your Elasticsearch and OpenSearch clusters. We have, on a high level, two areas that we need to focus on when it comes to Elasticsearch. We have the architecture, or what does my cluster look like? How does my cluster look? And then we have our data, broadly separated into two categories, structuring and operations. You'll find that a lot of these different modules overlap in the way that we function them. But data is, how do I use Elasticsearch? How am I searching in Elasticsearch, and how am I putting data into Elasticsearch? Let's start off with the hot-warm architecture. A discussion about hot-warm architecture, and you can see there are now many more layers that go into it, but a discussion about hot-warm architecture really comes down to a discussion about trade-offs. If you need all of your data to be on the best hardware that you have available because you want all of your searches to be as fast as possible and all of your indexing to be as fast as possible, you're going to have to stick with a hot layer. That's where you're going to get the best performance. If you can make some kind of trade-offs, for example, older data as it gets older, maybe you don't want to search in it as fast and you're not going to be indexing, now is when we start thinking about moving it on into the other tiers. You may have a use case where you want to go from hot and then you want to do some searching where you go to warm. You may have use cases where you go straight to frozen or ultra warm. Potentially other use cases where as soon as the data is no longer searched in the hot layer, we put it into a snapshot for any kind of auditing purposes later on, and then we delete it from our cluster. Delete the data is sometimes the cheapest option rather than moving the data between the tiers. If you're really not going to search it, maybe it makes sense to snapshot that or just delete it out of your cluster. The point here is make sure that you have only the layers and the tiering inside your cluster that you really need to meet your SLAs. Hardware profile is also important. Now, just because we've said hot layer doesn't mean that we have to go and buy the best NVMEs or SSDs available and stick those into our cluster so that we have as fast reads and writes as possible. Maybe we can get away with the cheaper SSDs or potentially even spinning disks. Usually not recommended to have any kind of spinning disks on your indexing layer due to Elasticsearch's internal parallel writes operations. But you can get away with spinning on, say, your warm tier or your other tiers as you go down. CPU is important, and these are all three different areas of Elasticsearch and OpenSearch. The CPU, the RAM, the storage, they can be scaled independently. Is your search CPU bound? Is your search RAM bound? If it is CPU bound, simply going to the next size up in your cloud providers may not be the best option. You're paying for extra RAM and extra storage that you may not need. So consider moving to a compute instance, for example, or if these clusters are running locally in your own data centers, consider adding just the resources that you need. Add more CPU or more RAM as and when you need it. Be sure to vertically scale Elasticsearch and OpenSearch until its limit, which is about 64 gigabytes of RAM with 30 gigabytes dedicated to the JVM. A 64 gigabyte node will perform better than two 32 gigabyte nodes. Availability is an important topic. If your clusters need to be up and running all the time and you need to be able to query from them, regardless of what's going on in data centers around the world, or perhaps in your region where you've got multiple availability zones in a cloud provider, then you're likely to need those clusters to run in those three availability zones. But the inter-availability zone transfer fees are expensive. And these costs do add up over time. So if you don't need that level of resiliency by having multiple AZs, consider bringing your cluster into one availability zone. The questions we need to ask ourselves are uptime, as already mentioned, and what is my disaster recovery scenario? Can I afford, while AZ1 is down, for my entire Elasticsearch cluster to be down, and then when it comes back up, or maybe I put it up into a new availability zone and restore from snapshots? Can I wait for that, or can't I? If I can't wait for that, then I likely need to stay in multiple AZs. Node roles. Only specialize node roles when you really need to. Just because there is master manager nodes, remote nodes, coordinating nodes, and so on inside Elasticsearch does not mean that you need to use them straight away. Every single role can be played by every single node in your Elasticsearch cluster. If you really do need the best performance, you probably want to think about specializing your nodes. But if you don't need the best performance, maybe it's a new cluster, maybe it's a small cluster, you can keep those roles limited and only specialize when you see the need to do so. Shards is very important in Elasticsearch to understand. Shards are the scaling factor of Elasticsearch. They are where the data is stored. They are the ones who are doing the searching. And how your shards look over your cluster is also very important. Too many small shards, for example, can be an issue. Elasticsearch has these shards who are instances of Lucene who have to use some CPU and RAM resources from the servers where they're running. This is improved in Elasticsearch 8.3. There's a new mechanism to put these shards into the nodes so that it doesn't use as much resources. But before then, we need to be careful about small shards. Conversely, we need to be concerned about larger shards as well. These come with their own set of issues. Slower recovery speed, say if you come from a snapshot into your cluster, slower search speeds, the more data that we have inside those shards, the more we're going to have problems potentially with aggregating over the data and searching in that data. We like to stick our Elasticsearch shards, Elasticsearch and OpenSearch shards. We like to keep them to approximately 10 gigabytes to 50 gigabytes. These are flexible observed sizes that happen inside of these different clusters, with the 50 gigabyte side of it more tiered or more tailored towards logging use cases, and with the 10 gigabyte size of it more tailored towards search use cases. I have these two purple shards in the third node to try and indicate an issue that we can see in many clusters called hotspotting, where you have some of your large shards dominating one particular node, and maybe that's the most searched and indexed indices in your cluster. So you have one node who is facing a lot of issues and other nodes who are not doing as much. So you're not utilizing your hardware as much as you can. In the next talk, Marcos will address how to detect these kinds of issues. Mappings are important for Elasticsearch. There is a saying that Elasticsearch is schemaless. This is not correct. Elasticsearch actually does have a schema. The schema is called mappings. And these mappings are important to establish inside your Elasticsearch inside your Elasticsearch and OpenSearch clusters. We want to define these before we really go into production. There are some tips and tricks to keep in mind with mappings as well. For example, there is a source enabled false function that allows you to disable your source if you really don't need to keep the raw data that comes along with ingesting your data into Elasticsearch. If you only care about searching the data and aggregating the data, you can disable the source, saving up to 30% disk space in some cases. Make sure that you map your fields to the correct forms. Strings are often mapped as text and keyword. This is not always necessary. Map it as text if you need to search in that data. If you don't care about scoring, you can disable the norms. If you only care about aggregating that data, you will store those strings as keyword, for example. And if you don't care about aggregating over the keyword data, but you want to keep it in keyword form just for filtering and faceting, you can disable doc values. Each one of these different functions, when enabled or disabled, will reduce the amount of storage space required, and it will reduce the amount of processing needed to index that documents in the first place, and it will help at search time as well. If you have numbers, make sure to stick them into their correct form, and there are many other field types to go through inside these systems. Our template optimizer tool is a free tool that we have on our website. You can put your template into it. And this free tool will actually go through your template and pull out many of the suggestions I spoke about on the previous slide and many more. It'll also nicely label them as urgent or not as urgent so that you can deal with them in your own time. As part of the AutoOps subscription, if you are subscribed to our AutoOps systems, these templates will be analyzed in real time. New templates that are added into your cluster will generate events if we see any of the issues in your mappings that we've discussed or that are listed here, or even further issues to be discovered over time. It's important to prepare for your disaster scenarios before you have any data really inside Elasticsearch. You don't want to try and put an index lifecycle management or an index state management in OpenSearch policy. You don't want to be dealing with these policies when your cluster is screaming at you, read only, allow delete. This is bad, this wastes performance, this wastes your time. This means that you're now no longer functional. That's going to cost you money, that's going to cost you time. So make sure to set up these index lifecycle management and state management policies ahead of time. Likewise, for snapshots, we want to have our snapshot policies ready to go before our availability zones drop out or before our clusters go down completely. A success story of ours, a customer of Opster, Cooper, by running through some of the tips and tricks that we spoke about in the previous slides, and by following a procedure on the next slide, we're able to achieve savings in their Elasticsearch clusters by over 60%. What we do is we have a conversation when we work with a customer, and the conversation can look something like this page. We first talk about mappings and queries, and we find if there are any ways to optimize them. We optimize the number of replicas. In the case of Coupa, they had 2 replicas, and we really found out that they didn't need that extra replica for that resiliency. So they dropped down to 1 replica, immediately eliminating the need for 1/3 of their resources. What is the requirement for live data? If you're really not searching in that data, after a week, a month, a year, whatever it happens to be, then why would we keep it in a cluster? In this case, we were able to move it out of the cluster and we could move it into the frozen tier. So we have the discussion about a mechanism for querying older data. Can you afford to wait for the restore and then search? Or do you need some search now immediately, but you don't have the time to wait for the restore? In Cooper's case, they could move all of their non-live data to their frozen tier. And then we would have discussions about things like how many data tiers do you need? In most cases, 1 or 2 tiers are enough. It's not every single use case where we need to go all the way through hot to frozen and so on. Another success story involved soft deletes, an internal mechanism inside of Elasticsearch that clears away deleted documents. When you delete a document or you update a document, Elasticsearch doesn't delete that document immediately. It marks it as deleted. This takes up disk space and it slows down certain queries inside of your clusters. The internal process that fixes this is called merging, and merging only activates once these delete thresholds reach certain quantities. So in the case of one of Opster's customers, we went over their cluster. We figured out that there were many deleted documents in many of their indices, but they weren't getting to the threshold where Elasticsearch was running that background process. We calculated the ratios of the deleted docs to all the docs. We then targeted the documents with the indices with the highest number of these soft deleted documents on them. And we ran a force merge, specifically a force merge with the only expunge deletes option. This is a relatively cheap operation that'll go and take away all those deletes. And in doing so, this customer was actually able to reduce their cluster by 10 data nodes. Wow, just by getting rid of these soft deletes on the cluster. That's great. In summary, we've spoken about many things from a very high level. Many of the topics that we've gone through on the previous slides can be entire 8-hour lectures. So Just to quickly summarize, only keep hot warm data if you need it. Try to use the ideal hardware to suit your specific use cases. Ensure that your ILM and ISM is in place before you get to a disaster situation to save you time and money later on. Make sure that you have snapshots for your older data if you need that. Maybe you don't need that. And many more topics that we haven't actually gone into and could be great topics for future webinars, like roll-ups for older data or optimizing your queries. And then a good one, talk to your cloud provider about some long-term discounts. These long-term discounts, maybe if you take out a set of nodes for a few years, you can get them cheaper than you might otherwise get them if you do spot instances. I believe they're called in AWS. Thank you. I'm Session. Check out our free cost insights tool as well, please. This is a great search some metadata about your cluster, and this cost insights tool will tell you what your what your estimated costs are and how much savings you can get simply by following some tips and tricks that this tool points out. Thank you. I'll hand it over. Let me stop sharing.
Hey, thank you very much, Sachin. Yeah, very interesting for sure. And yeah, I hope that, and now I will be talking about solving latency and performance issues in large cluster. I am Marcos. I was working with DevOps for a long time, more than 10 years, and then with Elasticsearch since version 2. And yeah, I would like to talk with you that with great power comes great complexity. Yeah, that's true. But don't worry, we are here to help you. To talk about latency and performance issues and complexity of your clusters and your shards and designs you have in your cluster. Well, first I would like to introduce what latency is. Latency refers to the time it takes for a request to be processed and a response to be received. It is usually the factor in determining the overall performance of a system, especially in large scale cluster. You know, the Elasticsearch OpenSearch clusters, the more nodes you have, the more complex it gets. And when I say complex, I mean that multi-tenant environments, what could lead to noise tenants, or several data sets in a large cluster with a lot of data nodes, what could lead to hotspots, multi-tier hosts like hot warm, or too much components like templates, indices, or shards, mappings, and so on, what will increase the cluster state. And you have a fast growth environment, so there's a lot of details we can't pay attention, and probably when your cluster starts to bottleneck or you see the latency growing, you need to add more nodes, what will create a lot of cost optimizations opportunity. And these are the most common challenges of large cluster, but for sure there's more. And here is where we start to face challenges that small clusters don't need to worry about. Issues on network, data replication and management, load balancing, resource management. At this point, adding more and more nodes to the cluster will barely help. Don't get me wrong, all the complexity we are talking about here. Can everybody hear me? Okay.
We hear you and we see you now.
Thank you, Sachin. I just saw a pop-up here in Zoom, sorry. So don't get me wrong, all the complexity we are talking about is not bad. It's just the result of some necessary implementations. For example, the hot warm. You could have the hardware of all of your nodes as hot, and don't worry about moving indices or shards to different tiers, but you would have a very expensive cluster as well. And that's why adding a warm layer would be good for you. You are adding complexity to the system, but it's a good trade-off. In this case, there are some factors like moving shards from hot tiers to warm tiers would add like maybe network saturation. It is a intensive I/O operation, so your disks would be under stress. And during this short presentation, I will be discussing more in details with you the noise tenants and hotspot issues, how to detect it and how to remediate it. The first issue I'd like to discuss with you is the noise tenant. And a noise tenant is the same issue we face with noise neighboring cloud. It's basically an expression for multiple clients or different applications sharing the same infrastructure, where one tenant is getting most of the bandwidth, disk I/O, CPU, memory, and so on. Resources which can negatively affect the other users' performance sharing that infrastructure. The noise tenant effect calls other indices in Elasticsearch and OpenSearch and applications that share the resources with the noise tenant to suffer from uneven performance. We can say that the issue starts when one tenant is using more resources than expected or more than what you planned for it. To detect the issue, we can use any monitoring tool providing the list of indices that have active indexing activity, list of slow indexing nodes, collect index level stats. We would also need to calculate indexing latents per index. We can call that a suspect indices list because those are the slowest indices. And then detect the noise one from the suspects indices list. You can get all the information you need from built-in monitoring or Prometheus exporter, for example. Seeing the information in a chart is really useful. The only problem here is that the list of indices receiving requests can be huge. Also, when we say slow here, I mean slow when we are comparing one node with others. So yes, more metrics to investigate. Once the noise index is identified, it's time to fix it. So here's the remediation. You can apply one or many of these items. And well, just for high level, add more primary shards or adjust the number of primary shards. We can, one index is created with with the defined number of primary shards it will have. We have options like _split endpoint to redefine or reshape the number of primary shards of an index. It's still, depending the use case, you will need to create a new index or roll over it with the new settings. Adjust the number of replicas is another remediation. Replica shard is for data failover, and it can also increase the throughput per second for search use cases when you have hardware for that. And it also helps you to decrease the latency when you have more replica shards, because just to give you an example, let's say that you have one index with one primary shard only, and your cluster have 10 data nodes available to receive this shard. If you add one replica to each data node, the cluster will be intelligent and will select the best nodes to run the request, the query. However, having too much replicas or maybe If it's not well designed, you will face problems because of that as well. So adjust the number of replicas is important. Use slow indexing logs to analyze. This is another remediation. Well, this is the step to remediate. Actually, you need to analyze the slow logs, and because sometimes one single request is causing the issue. And adjust mappings is an important part as well. Having a well-defined mapping can avoid problems like field explosion, where you have too many fields in your index. It will avoid storage issues because the default mapping of Elastic will may create too much data structures you don't need, or unwanted structures. And yeah, users also can use those structures that are not well defined. So defining a mapping and settings or templates, it will be very good. And the last option to remediate that I would like to discuss with you is isolate the node, isolate the tenant to a node or a dedicated cluster. Hardware overcommitment is okay as well. In AutoOps, we can help you with the described steps for detection and resolution. And these are the examples I get to share with you, where we have here the event where we detected a tenant using too much resource. And here is an easy way to filter and search for suspects list by yourself using index filters and a time window to investigate it. In this example, we are sorting indices based on indexing latents here. Now, talking a bit more about hotspot issue. Hotspots are the situations where load is concentrated on a subset of nodes, causing bottlenecks and impacting performance. Hotspot, you can say like, I am having a indexing hotspot, or I am having a search hotspot. We can say it's similar to the noise tenant issue we just discussed. The cause will be different, but the impact will be similar. Like if you have multiple data sets being ingested to your cluster, metrics and logs, for example, but one application you are ingesting just start to ingest like 100 times more logs than usual. Someone changed it to trace level. And the hotspot issue will make certain nodes to run over capacity, because some shards will be allocated to a few nodes only, and let's say that the index logging, the log index receiving all those extra documents is only in a few nodes. So it's usually easy to see a higher node usage while checking metrics per nodes. After that, we can check the workload based on shard activity and identify which shard is impacting that node. This is the detection phase. This case, I believe it is a bit easier when comparing the noise tenant, because one tenant only usually have a well-known and predictable behavior, like your applications. The problem on searching for the root cause in this scenario is that it's not just one factor or metric that will be spiking on your monitoring system. Several metrics may mislead you during the investigation. That happens because all the resources are interconnected. So if the node is missing memory for indexer buffer, for example, the JVM will start to trigger a lot of garbage collector, which will increase the load and CPU usage. But the problem is not exactly the CPU or the garbage collector type, just to mention an example here. This is how the hotspot issue will look like in Elasticsearch built-in monitoring. When accessing nodes, node metrics, each node in the cluster we will have something like that. This is a small and test cluster. We will have the indexing time, for example. This is the total time that the node is spending on indexing requests. And we also have the request rate. As you can see, one node is having less requests than the other, and at some time it changes. And at the same rate, the indexing time is proportional to the request rate. So the more request rate we have, the more indexing time we are expanding here. Still on node view, now we are going to see why it's happening. After selecting which node you'd like to see the metrics, you are also able to see which shard is allocated on that node. I believe many of you have already found the problem here, but as you can see, in this small test, we have logs, indices, and I can see I have usually 3 shards, shards 0, 1, and 2. So I have 3 shards for this index pattern. However, I have only 2 nodes. So my logs indices have 3 primary shards and my cluster 2 data nodes, which means for these indices, one node will always have double the workload because the shard is the unit of scale, as Hashim mentioned, and all the requests are processed by shards. So if I have more shards in one node, that node will work more. In this example, it's really simple to see it, but it is a small and test cluster. On production or large cluster, it's not so easy. Not to mention the number of nodes and indices you would need to check manually, and inferences you would need to make because the built-in monitoring really don't provide the metric we need in this issue, to check this issue. As the workload information on built-in monitoring is only on index level, which makes it impossible to say which node is doing what, we will need to collect it, but from shard level. One metric you can collect to fill this gap is shard activity with _cat/shards endpoint, like in my example. This is the easy way to find the workload aggregated by node and index, or shard in this case. Then all you need to do is to calculate the delta between the executions. Like in my example, I have the index logs and the date, and the number of the shard is 1. It is allocated on instance 1. After some time, it is still the same index and shard, but the number of documents has changed. And it's the same for all the other nodes and shards of that index. So it is easy to aggregate and find the information we are looking for using this endpoint. In AutoOps dashboard, for example, this is how we present the information of _cat shards. We have here the action we are looking for, in this case, the indexing rate. And then here we have all the nodes of the cluster. As you can see, there are several nodes. And here we have the list of indices. And then we can see that in some cases, we have even the same index in all of the data nodes. But in some indices, this is not the case. And some indices is receiving really high number of requests, as in this case. And it's causing the nodes to be not well balanced in workload. As you can see, there are nodes processing like 10,000 requests per second, and another node processing like 2,000 requests per second. So this is a hotspot issue. And this is how the AutoOps platform will automatically detect the event, provides you the context and the suggestions. And talking about suggestions and remediation, the goal to remediate this issue is to balance the workload. As shard is the unit of scale again, all we need to do is to rebalance the shards as well. There are many approaches we can apply here, like just move the shards to a different node, or adjusting the number of shards. Like in my example, the root cause was having too much primary shards in just one node. So in this case, the solution would not be to add more primary shards, but decrease the number of primary shards. We can also have an approach like update templates with shard design settings, like shard filter, awareness, or shard limit, and so on. Just to give you another example, these shards are located in this node. But why is it allocated here? Was it just Elasticsearch selecting this node automatically? Or is it here because of a filter? So this is something that we can control as well. And when we can control that, we can have a better, a better performance and avoid bottlenecks, decreasing the latency of the system. There are really a great variety of settings and best practices we can apply to fix or avoid issues like this. Some suggestions here are applicable to any scenario. Others are more specific or difficult to apply and may add extra complexity. For example, if you are running an indexing use case, but suddenly someone starts to test queries in your system, then you may start to face cache problems on search, It's not an extensive list. There are much more than this. I just listed it here to demonstrate the great variety. We have to solve different performance and latency issues. And to summarize, this is why it is important to monitor your cluster. There are issues and use cases really hard to operate and troubleshoot. It's possible to avoid many of these problems, but troubleshooting issues in large cluster can be hard. Just add more nodes may not help, but we can always help you with that. You can take a free trial. I hope you enjoyed, and thank you. Tal, with you.
I can take it. Thank you
nice.
so much, Marcos. If you can just move to the next slide and stay there. So this is the Q&A section. So there were a few questions along the slides. I hope first that you really enjoyed the lectures. I know these are tough subjects with many details and we covered many things, so it might take some time to digest. Cost reduction, hotspots, noisy tenants, these are challenging cases indeed. So let's move on to the questions. I see that Sachin has answered few, so let's do this interactive. I want to start with the first one. When would it be beneficial to split node roles? You mentioned when needed, but how can we track need in relation to ingest performance and master performance or impact on data node? So the question here is whether to use a node with multiple roles or to have dedicated nodes. Like Sachin said, this is a trade-off. It's always the trade-off of cost and performance. So of course, if you have dedicated nodes for every role, you will get better performance because each node will be focused on smaller workloads, and the other trade-off is cost. So it's the resources, you'll have more nodes, you pay more. So when will it be beneficial to split nodes? It depends. It depends on the performance you need and the SLA you want to stand with. If there's a lot of ingestion going on all the time, it might make sense to have dedicated ingest node. On other cases, dedicated master nodes are important on large scale cluster where the cluster state, like Marcos mentioned, is too big. So it is important to have a resilient discovery. You would like on a bigger cluster to have dedicated masters. Anything you would like to add, guys?
Yes, I do. If you have maybe heavy ingest pipelines, you've moved to the Elasticsearch ingest nodes, the Elasticsearch OpenSearch ingest nodes, and maybe you've gone away from Logstash. These pipelines can be very heavy. These are times to think about maybe using ingest nodes.
Great. let's move on. I hope it helps. Is it possible to schedule force merge? I know you answer it, Sachin, so maybe you can give an answer here.
Yes, so there's no inbuilt function inside the software to schedule that. There is a process going on all the time in the background, which is doing these merges. But as I said, they only target the mergers once the document delete counts gets too big. I think it's 30% by default. So there's nothing to schedule that. And usually it's probably not recommended. I know it's a light operation, but anything that's scheduled runs the risk of interfering with your operations inside your cluster. There are tools to do that, or if you want to script it, maybe you have a very heavy logging use case, search use case, where you have one big index, then you're doing lots of deletes and lots of updates, maybe then, but then be careful about the time. Don't run it every minute, for example, maybe once a day or once a week.
Right. Thank you.
Something
for
to add there, Ziv?
No, that sounds perfectly right to me as well. Next question, what tools are available for working with OpenSearch? So that's a wide question when talking about tools, can be multiple tools. So if I understand it correctly, let's start with monitoring tools. You have the Prometheus exporter, and you can use Grafana with that Prometheus exporter to monitor stuff going on in OpenSearch. And there are other ways. There's the other open source tools out there. I think Cerebro still works with OpenSearch as well. Is there any common strategy to speed up search in warm nodes? Speaking about petabytes of data stored there. So that's a good question. That's exactly the trade-off, whether you want best performance or reduction of cost. So if you want best performance, the data should be, of course, in the hot tier, where you have more resources and the ratio of disk to memory is better. But on warm node, you have bigger disks, the ratio to memory is worse, and it might impact performance, of course. The best practices are, of course, to remodel the data better, to restructure the queries in an optimal way, to query only the data you need to query and not to query everything all the time if you can. So these are my tips. If you have something to add, guys.
I have one, force merge. Force merge will usually always help when you don't have more write activity in the index or update. Force merge usually always help.
Force merge segments one.
Segments one, yes, exactly.
Yeah.
Good tip, great one. The next question by Kirill, can you share the presentation? Yes, we will. We will share it. You will probably get a video and email in the coming day or so. Is it possible to separate indexing and search activity on node shard so search is given more priority over indexing? Well, I think this is a bit complicated question because it can go to multiple directions. So let me just rephrase it. What is the best architecture for a cluster if you want to control how much search resources you're going to have in it and how many resources you're going to have to indexing and being able to control those? So of course, the serverless Elasticsearch and serverless OpenSearch are a future way to achieve these. Currently, dedicated nodes, controlling the number of primaries and replicas, like Sachin mentioned, ingest nodes for doing most of the indexing work outside of the nodes that runs the searches. These are all ways to have some separations. Guys, you want to add something?
In theory, cross-cluster replication can do that, but then there are some caveats that you need to keep in mind with cross-cluster replication.
Yes,
to an extent.
Yeah, you would have one cluster for write and another for search, for example.
In theory.
Yeah,
but yeah,
theory.
Like Ziv said, the serverless is really the teams at Elastic and OpenSearch are trying to build that serverless to solve exactly that problem.
Yes.
Yes,
And
and
it's not an
there's a
easy
way to
problem to solve.
overcome that. It's not easy. You can get to a pretty similar architecture, but by having ingest nodes, ingesting the data, taking snapshots, and a frozen tier that runs on that. And so having hot tier and frozen tier. Yeah, so these are some ideas how to achieve such a thing. The tool shown earlier in the presentation that is used for determining overall cost and cost saving, does it work for on-premise instances?
That's a great question. Yeah.
By Jeremy. So let me answer that quickly. The tool that was shown is available on Opster website. It's called the Cost Insights. And it only takes you to extract 2 JSONs from the cluster one time and to put them as an input to the tool, and it will analyze it. So yes, the answer is yes. You can run these 2 commands against your on-premise cluster. Take the output JSON and paste it on the tool, 2 commands. There's no sensitive data. It's cat shards and I believe node stat, and that's it. So you can do that.
On any, on-premise, in the cloud, in the Elastic cloud, wherever that cluster is.
Exactly. Thank you for that, Sachin. Another question, do you need a dedicated master nodes for an indexing only cluster, no searching? So the normal answer starts with it depends, because really it depends on the size of the cluster, on the SLA you want to have. So let's take a look at the question again. And if it's only indexing cluster, let's say it's like the example of CCR, you index into one cluster, you take it to another to search. So if the cluster only have indexing, it depends on the availability you need, because and the size of the cluster, I believe, like large clusters with large cluster metadata, many indices, many nodes, it might need dedicated master to manage large cluster state that can reach half a gig or more. So for these large cluster states, you would like to have dedicated masters, regardless if it's indexing only.
Yes, I would like to add.
Yeah.
No,
Go,
yeah,
Marcos.
the cluster, the master, dedicated master, usually are good for keep the cluster quorum. And also, well, a good metric you can use is how much the data nodes you have on your cluster is using for the resources you have for it. Let's say that it's almost like 70%. If only the data nodes is on almost 70% plus the master nodes, that probably is a bad scenario already.
I'd also like to add the master nodes function. I think they're going to change it to manage a node now in OpenSearch. That function is to, it's changed already, is to look after the cluster. That's the job of that role. It doesn't help in searching in any way. So if you were thinking of sending the requests to those nodes, don't do that. Send them to the data nodes.
Yes.
And here's another interesting question, a short one, ingest nodes versus Logstash. Well, that's a discussion really, although the question is short. I can give my take on it. If you use ingest node, use ingest pipeline. I believe Logstash provide a bit more flexibility because you can scale it by itself, not part of the cluster. That's one thing. The second is with ingest pipeline, when you fire the index request or the bulk request, you need to specify the ingest pipeline you want to traverse that document through. And that gives you a coupling in some cases between the shippers, the bits agents, and Elasticsearch and the ingest nodes. Whether in Logstash, you control everything in a single place, you can manage it, you can play with it and change it more flexibly. Guys, you got something to add to this?
I think you covered it. Yeah, it's a complicated question.
Yeah.
Great. Let's move on. And we have many questions. We might not get till the end. We have a few more minutes. We'll try to answer. Regarding snapshot management, after indices being snapshot and being deleted, there are still available in snapshot. How to clean up the snapshot as well? Does snapshot management handle it automatically?
In the snapshot
Or Sachin?
lifecycle, yeah. So the snapshot lifecycle management in Elasticsearch and the snapshot management in OpenSearch, they do have a function to delete that data over time.
Yes.
Yes, so you should be able to
It is not
delete that
recommended to
using...
touch that repo manually at all. You should leave that repo alone because there's lots of metadata files and things in there. So yeah, there's definitely a function.
As well as data director of Elasticsearch and OpenSearch as well.
Yes.
Yes, so that's important. So you should not go into the blob storage and start cleaning up and deleting objects by yourself. You should use the snapshot management commands and use that to set the retention. For ingest and index performance, what option would you suggest that will help? I guess adding one more primary shard would work. Let's read that again. So the question is about indexing performance. And if you want to increase indexing performance, I guess, would adding another primary work? Again, it depends where that extra primary is allocated. You can think of the nodes as the ones that have a throughput and capability based on their hardware and the number of threads. This is the nodes. So if you're going to add more and more shards to the same node and index to all of those, eventually you will reach the limit of the node. So on that case, if you're going to add more primaries, it will not help because, again, the node reached the limit. But if you're going to have another node that is idle and put another primary over there, you will get more throughput by adding more primaries. FluentBit or Logstash with OpenSearch? Many interesting questions. Okay, so I know that the OpenSearch team did some surveys and looked around for what would be the best. So I think Fluent is the platform they decided to focus on. Logstash can be an agent and a shipper, but usually is doing the ETL. There is another tool in OpenSearch stack. It's called Data Prepper that is more suitable to be maybe a replacement of Logstash if needed. Hope that helps. One last question before I summarize this. What's the memory to disk ratio for hot and warm tiers? Oh, that's a great one. So I don't think we can answer it straight away. There are some best practices numbers, guys, if you can shoot from your head. But what I would recommend is checking the Cost Insight tool that checks those ratios. Do you have them in the top of your head, guys?
No, it's one of those great it depends questions with Elasticsearch and OpenSearch.
Yeah, it's a bit complicated and it changes over versions as well. Yes.
Yeah,
Marcus.
but just to mention a number, we say hot when it's like 1 to 8, the disk memory ratio. Warm is up to 15, and colds and froze will be starting on 30. But yeah, it depends. It depends a lot.
Yeah, with frozen, it can be many times more than that because of the whole caching thing.
Yeah, like
the data is in the repo, and you only have some of the data in the node. It's a difficult question, that one.
So we just reached the end, exactly 1 hour, and we finished covering all the questions. Thank you, Sachin and Marcos, and thank you for all the participants joining. To finish, I would like to remind you that Opster have AutoOps, the cloud service, and these days you have a free trial, self-service. So all you need to do is go to opster.com and visit that AutoOps page. You can create an account by yourself and connect a cluster, self-service very easily. You will have the expert team to help you if you need help connecting. and try it out. It will help you achieve some optimization, some performance tuning and cost reduction. And you can start that for free for 2 weeks and play with it by yourself. Thank you very much, everyone. I hope you enjoyed this session.
Have a great day.
Thank you, everyone.